Hi everybody and welcome to a short little catch-up video on how to do cubes and nets. My name is Luke Lloyd and we're going to spend a few minutes now just going over some of the core principles, the core ideas, so we can exercise this, which is one of the more difficult topics. And cubes and nets, just so we know, is probably for me, I think one of the ones that I find my students find most difficult for all the NVRs, and that's both for CEM and for GL assessment. Cubes and nets always tends to be a bit of a sticking point. But don't worry, because we'll talk through it. We've broken it down to the small steps, and hopefully you'll find it thoroughly accessible. So I've shown this slide very frequently. This is going to be a little useful skill just possibly for the next slide. So very quick recap, how to draw a cube. You might want to do this for note taking. You might want to do this so you can draw your own examples and have a little play about what might happen. You know, if you ever, once you eventually get to the situation where you can draw a net and then successfully, correctly and accurately draw the cube, well, that's fantastic practice. It's a way of generating your questions. So very quickly, just to draw any cube, draw the front face. That would be to draw a square. Draw the same exact shape as close as you can, but offset it slightly. Generally speaking, if you offset it by a quarter, that's about perfect. So I'm going to put it roughly in the middle. So you can see I've drawn the same thing twice, and now we can just join all the corners up, and that will produce a pretty good cube every time. And so that's useful because you may want to do notes. If you are on the next slide, and I'll share something, I recommend drawing a nice big one because that'll make the labeling far easier. And this will help for all sorts of NVR questions. So it's just a useful little skill. Let's now go through the 4 tips, the 4 hints for how to do the cubes and net style questions. So generally with the cubes and net style questions, you'll be given a net and you'll be asked which of the following cubes can be made from the net. Now sometimes they change it and do it in reverse, and much the same steps apply, but this is by far the more common, so this is the one I'm going to be going through today, and it's certainly the one that relates to the more recent homeworks that we've had. You can see I've got my net, and on it the faces have numbers. Now, sometimes there'll be letters, sometimes there'll be shapes, sometimes there'll be numbers. The reason I've chosen numbers for this example is just because they stand out, and it's quite easy to notice if a number is back to front or the wrong way around. So you'll see that in just a moment. But again, they can be all sorts. If we're going to try and identify whether a cube can be made from this net, the first thing I'd recommend looking for is things to eliminate, just generally. You want to try and find the ones that are wrong. This, out of all the question types, is perhaps the only one where I would always suggest to all students that you eliminate every single option. So I want to be left with just one thing left that is the answer, because I've gone through and I've removed the others. With other shapes, quite often it's more efficient, or other shapes, with other question styles, it's more efficient to look for the correct answer. So for example, for verbal, if you're doing a definition and you're asked what a word means and you know the meaning, well, it's much faster, rather than eliminating the wrong answers, just to go to the correct answer. Well, for this, I actually recommend, certainly while you're learning, to go through and prove to yourself why all the other options are wrong, leaving you with only one answer. And that, for this, I think is certainly the approach for learning, and even in the exam, I will often advise that, just to be really clear on what the correct answer is. Step 1 for how to identify an incorrect cube, or a cube we're going to eliminate, is to look for the alien shapes. Now, alien shapes are shapes that have a feature on them that cannot exist. So if I have a net and I fold up this net full of numbers, it is not possible for me to end up with a cube with a smiley face on it. That is an example of an alien shape. It's a shape that's appeared out of nowhere. It's an imposter. It can't be there. The shape on the right is a perhaps slightly more subtle and perhaps potentially more common version of alien shape, where again I sort of call this an imposter alien, where it's sort of hiding, pretending to be another. You can see that we've got 2 3s here. And although we have a 3 on the net, we don't have 2 of them. It's not possible, no matter what way I fold this, to end up with a duplicate, 2 3s next to each other, nor is it possible to end up with a new shape. So this is the easiest thing to spot, and this is the first thing I suggest you should look through. Are there any cubes that have a feature that just can't be there, that's an alien, that is just turned up out of nowhere, that's not possible? These are really quick, they're sort of instant, you just spot them, nope, can't be it, cross it out and eliminate it. I know the game Among Us is very popular at the moment, where you've got imposters hiding among the crew. That's how I remember these. They're sort of imposter shapes that are turning up. They're secret aliens, they're trying to blend in, but they're not allowed. So that's my way of sort of remembering what to look for with alien shapes. This is the easiest. This should take no time. The next one to look for, again, in my opinion, it's the next easiest, and quite often between just steps 1 and 2, that will sometimes be sufficient to enable you to eliminate enough options so there's only one left. And step 2 is to look for pairs. So I say eat up the pears. That's just a fun way of remembering it. Of course, I don't mean pears the fruit. What I actually mean are the pairs on the net that can't be next to each other. do you notice the color coding? I've got here blue and blue, red and red, and purple. That's actually intentional in this diagram, and you can actually buy these magnetic cube sets if you are struggling. This is something you may want to look out for, because you can actually then draw on them and 3D model it. Now, I don't tend to like using these for actual practice, because you won't be allowed on the exam, but they're a fantastic tool for just getting it very clear in your head. You can also achieve this by sort of sketching out a potential net and then sketching out the cubes that can be made from it. But let me just home in here on these two blue examples. You can see they're on either side. If I was to fold this up, and if you can visualize how we were to fold this net up to create a cube, hopefully you can see that they'd currently be on the wings, we'd fold them up, and they'd end up being on opposite sides. So if I'm looking in this direction, there's no way for me to see this backhand that's facing you. I mean, I can see this side, but I can't see this. And vice versa, if I looked from this side, I could never see this side. So it is not possible for me to end up with a cube where I can see the 5 and the 6 at the same time. Because they're on opposite sides, I'd only ever be able to see one or the other. Hopefully that's clear. And so 1 and 3, again, when I fold them, will appear on opposite sides, so I can never see them on the same cube, and 2 and 4. The same is true for all these combinations. What this means is, if you ever find, I call it a pair violation, something that violates the rules of the pairs that isn't allowed, you can immediately, without further consideration, just eliminate it. So how do we spot the pairs? The general rule would be, first and foremost, they have to be separated in the same plane by a gap of 1. What do I mean by that? Well, you'll notice here, going in the same direction, so the same plane going across, there is a gap of 1. So 5, gap 6. That's how you know that when they fold, they won't be aligned with each other. You can also visualize it. I don't recommend this necessarily for the exam, but another way of just doing it, certainly as you start, is you might want to number them. So obviously this is color coded, but if it was an exam, it wouldn't be. So I would simply say to myself, well, look, here's a pair. So there's pair 1 and 1 for those two blue ones. Here's a pair 2 and 2 for these purple ones. And here's pair 3 and 3 for these red ones. And you might just write that in the corner or write that nearby, just so you're making a note for yourself. And it means then you're not having to check back. Again, hopefully I want you all to get to the stage where you can do it visually in your mind. But just as a starter, that's a nice little tip just to get you on the right track. Now, as I say, between these two steps, these are the easiest steps because they're quite simple. Does it exist? If so, cross it out. Or are they pairs? Do they break the rule? If so, cross it out. That will actually answer quite a few questions alone. And so that's why we start with these, because they're quick, they're easy, and sometimes they'll get you to the answer. There's 2 more stages that, again, are slightly more complicated to look at. Again, 3 is sort of intermediate, and then 4 is perhaps the most rare and sometimes the most difficult to spot. Step number 3 is to consider rotation. And the way I write this is to add arrows and tails. What I mean by add arrows and tails things is ask yourself what's pointing at what, or what's behind what, and that's what I mean about the tail. But essentially it's consider the rotation of the shapes. If you look at the example here, one of these is correct and one of these is wrong. One of these is more correct than the other. And the reason it's correct is if you look, this 1 is pointing at a 5. But this one is pointing at the 2. And it can't be both. So if we go back to our net and we add on an equivalent arrow, so at the end of our 1, you'll notice this 1 is aligned and should be pointing to the top of a 2, not the 5. If I was to join these 2 round, what you'd actually find is you'd find, if I was to draw this purple shape, I'm going to rub everything out. If I was to draw this purple shape so that it was next door, what you'd actually find is that the blue one, would be horizontal, like this, not pointing at the 5. And that's really important, and that alone is sufficient grounds for us to eliminate. So my advice, look for rotation. The best way to do that is to find things that can be made into arrowheads. And again, my favorite shapes are obviously if they give you an arrow, well, that's brilliant. But triangles, of course, only one short step away from becoming, if you add a tail, it very quickly then becomes an arrow, so you can think about what direction it's pointing. The letter 1, for example, it's going to be pointing at 2 features in 2 directions. Rectangles are one where you can actually think, well, yeah, the tall part of my rectangle should be pointing. I've seen shapes like the letter E. Obviously, the letter E has a back, so this would be the back of the E, and it has then the front. So you can ask yourself, well, what should the back be facing? What should the front be facing? I've even seen, so again, this is the idea of adding tails. I've even seen sort of patterns like this lollipop swirl, or sorry, a swirl shape that then got turned into a lollipop. And then you can, as long as you're consistent with your directions, or again, another way, you could put a little arrow on there and say, okay, well, what's that part pointing at? There's loads of ways of giving yourself a distinguishing feature and saying, well, what should this be pointing at? What should this be facing? And by doing that, at the end, it makes it very quick, very fast to be able to say, is it pointing at the right shape? If not, eliminate it, move on. Now, certainly between these three, you'll be able to answer 80 to 90% of the questions, I think, alone. So if I never taught you step 4, that will be sufficient for most of them. However, normally, if you get to this stage and you've still got a couple of options left, the last step is either a really difficult direction one, where it's really subtle, or this last step, which is, again, I don't have a catchy name for this one, but essentially it's to consider, is it a left-handed shape or a right-handed shape? Is it left or right? And so my first question actually that I would ask is, are these two cubes here the same? And the answer to that is no, they're not. You can't, 1, 2, 3 and 1, 3, 2, no matter how you rotate and orientate this, if you were to create these cubes and have them nearby, they would never quite match up. And they don't quite match up in the same way that if you look, my hands don't match up. If I know how much I overlap them, either my thumbs are sticking out, or if I overlap it so that my thumbs are in the same direction, my fingers are going in opposite directions. And that's if I keep the palms facing in the same direction. So I keep my palms facing down or my knuckles facing up. I can never have them overline or overlap. And that's because these are actually mirror images of one another. They're actually reflections, and that's one thing you'll notice. Again, notice my hand, they're sort of mirror reflections of one another. Because they're not the same, that again is grounds for elimination. The best way I found to spot these, and so for example, my question would be, is 1, 2, 5 possible to be made from this net? The best way to spot this is to give yourself a top, so to somewhat arbitrarily decide which one is the top of the shape, and then assign a left and right on the cube and a left and right on the net and see if they match up. So here's going to be an easy example. I'm going to say, well, obviously, look, the 1 is the top. And if I was looking at this cube such that it all folded up to make the 1 the top, you can see that I would have the 5 on the left and the 2 on the right. And if I then do the same thing, well, look here, this has got the 2 on the left. That already is a mismatch. This is not the same. You cannot make this net from the above cube because the 2 and the 5 are on the wrong side. But again, making a decision. Okay, I'm going to call this the top. I'm going to look at it now from this direction. One thing to be clear, now obviously left and right here are the same. If I was to ask you, perhaps this is a little challenge question, I'll do this for you all. If I was to ask you, what would it look like if I had a cube? Let me just draw one. If I had a cube here, and the 2 was on top, and I was going to have a combination of 1 and 6. So I want you to put 1 and 6 for me on these faces. Which order would they go in? Would it be that the 1 is on the left and 6 is on the right, or something different? Pause now if you want to have a go, because I'm about to reveal the answer. The answer is actually no. In order to orientate my shape so that this is on the top, I'd have to look at it from this direction. Can you imagine that? So I'd have to look at it from the direction of the arrow to make the 2 at the furthest at the top. And that would then mean if I was looking from that direction, looking down, the 6 would appear on my left and the 1 would appear on my right. So the correct orientation to actually make this correct is to have the 1 on the right and the 6 on the left. And actually in terms of orientation again, notice that the back of this 6 should actually be facing the back of this 2. So actually to make this perfectly correct, the 2 should be orientated that way. Not to worry about that for now, but hopefully you can see that the 6 and the 1 need to be aligned in that way. And again, that's why I think this is perhaps the hardest one to spot, which is why I leave it for last. And quite often it won't even come up. Or you might be able to, as we saw with this one, the orientation actually may have given the answer away before even needing to consider left versus right. But again, if you're particularly talented at spotting left and right, maybe more so than you are at rotations, you can choose to mix these, but certainly my advice would be to keep 1 and 2 locked in, as they're always the first things you consider. And then 3 and 4, for me, I think 3 is easier to spot, but you could perhaps make an argument that if you spot a 4, obviously eliminate it at that time, don't wait. So those are the key steps, and I think that's just really important and really worth highlighting. And again, I would thoroughly encourage you, as in terms of next steps, to make a note. Obviously, I've written out examples. I suggest you please do the same. You're welcome to choose my same examples with the numbers and copy these out into your book so you've got them handy. But you may also, as well as doing that, you may want to then create your own, draw some shapes, put some circles, squares, and triangles in there, and see if you can actually then create from the net that you've given yourself 3 or 4 different cubes, all from different angles, and see how they would look and see if you can follow the rules. Are they obeying the pair rules? Is everything pointing at the correct shape? That's a really fantastic way to practice this skill. I know we've handed out some quite challenging homeworks that go with these. But again, this is the classic example, and this really is the goal. If you have these in the future, but just say thank you for watching. See you next week. And again, if there are any questions, don't hesitate to go and actually watch the homework videos that pair with the videos. They'll be really useful. Or of course, get help from your tutor or get in contact with us. I know parents' evenings are coming up soon. That's a fantastic chance if you want any one-to-one help. Brilliant, everybody. I'm going to finish there. Thanks so much for your time. Speak to you again soon. Bye-bye for now.